Good evening and welcome. This is the third Ariane 5 launch of the year and the fourth launch for Arianespace, since as you'll remember, we began this year with the first Vega launch. This evening we have two very important Arianespace customers with two very different satellites. One of them is EchoStar XVII, a large telecommunications satellite for Hughes, which is entrusting a satellite to Arianespace for the second time. EchoStar XVII will be providing high-speed broadband internet services across the entire North American continent. The other satellite is MSG-3 for Eumetsat, a very loyal Arianespace customer, for which this will be our 9th satellite launch. MSG-3 will be providing continuity of services for Eumetsat, the European Operating Agency for Weather Monitoring. So as you can see, Ariane 5, the world's most reliable heavy-lift launcher, is once again demonstrating its versatility. This is a very busy year for Arianespace, with Vega maiden flights, a total of 7 Ariane 5 launches and 2 Soyuz launches from French Guiana. Our goal this year is therefore 10 launches from the Guiana Space Center. And without further ado, let us now watch this one, Ariane 5 ECA, EchoStar XVII and MSG-3.
Hello and welcome. We're live at the Guiana Space Center for the 4th launch this year from the European spaceport on the edge of the Amazon. There's Ariane on the pad, going through the final preparations before launch. I'm Katie Haswell, and joining me in the commentary box is our technical expert from Arianespace, Simon Thompson.
Yes, hello and welcome. And on board today we have 2 passengers, EchoStar XVII for Hughes Network Systems and MSG-3 for Eumetsat.
And there we have the status panels on the left-hand side of the screen.
And right now everything is green, so all the systems are go for launch.
Ariane 5 is a big, strong, reliable workhorse. She's actually divided into 3 main sections. We call them stages.
Yes, we have the solid rocket boosters. We have a height of 31.6 meters, 278 tons.
The main cryogenic stage is 31 meters high with a mass of 188 tons. It burns the Vulcan 2 engine.
And the upper stage, the upper cryogenic stage, at a height of 4.71 meters, it weighs 19 tons.
And that structure at the top of the vehicle, the pointy structure, is the fairing. It's 17 meters high and it weighs 2.8 tons. That's where our satellites are right now, underneath the fairing. This is mission control. It's 15 kilometers from the pad. Everybody here calls it Jupiter. And this is where Simon and I have our commentary box. Now we're looking at a special group of people here, the Flight Directorate.
Indeed, and the head of the Flight Directorate is Jean-Yves Le Gall. This group represents the highest launch operations technical authority that we have. They have a final say in any case of unplanned situations. The teams we have working across the base, they report directly to them in real time.
And right now the satellites are tucked up underneath the fairing, that structure we just saw at the top of the launcher. There they are, under there. What's it like in there, Simon?
Well, actually, it's quite nice and cool in there. We control all the conditions very carefully and to suit each of the passengers. For example, the air conditioning flow rates and the temperatures. And we monitor these conditions from the moment we encapsulate the satellites right up to launch.
And there they are inside.
Indeed.
EchoStar on the top.
EchoStar XVII for the Hughes Network Systems. It's a satellite internet service provider, and it has a mass of 6 tons today.
Underneath it, but we can't actually see it because there's the cylinder, is MSG-3 for Eumetsat. It's a meteorological satellite. Its mass is 2032 kilograms, and it'll have an orbital position of 0 degrees north. EchoStar XVII was built by Space Systems Loral at Palo Alto.
Yes, and it's a next-generation Ka-band satellite providing high-speed internet services at well over 100 gigabits per second. That's quite impressive.
It certainly is, very powerful. Arianespace launched the first satellite for Hughes That was Spaceway 3, and it's delighted to be orbiting this second one today.
It's a pleasure to serve again tonight Hughes Network Systems, now owned by EchoStar Corporation. Hughes uses high-throughput Ka-band satellites to provide consumers and enterprises with high-speed internet services everywhere in North America. These services, commercialized under the HughesNet brand, are so successful that Hughes had to order and launch a second satellite to complement Spaceway 3, the other big bird which was already launched by Arianespace. Personally, I was given the opportunity to pursue another career internally at Arianespace, and tonight's flight will conclude the last launch services I conducted as a program director within the company. There is a special link which ties me with Hughes. Indeed, the first program I was in charge of was Spaceway 3, launched by an Ariane 5 vehicle in August 2007. Hughes somehow enabled me to open a loop, which I'm closing tonight, with Hughes again for EchoStar XVII.
Well, our other passenger is Meteosat second generation 3.
And Thales Alenia Space is the prime contractor. They built this satellite for Europe's weather organization, Eumetsat and ESA.
Since the 80s, Meteosats have been helping experts to improve weather forecasting immeasurably, and Arianespace is proud to be playing its part.
MSG-3 will be the 9th Meteosat series satellite to be launched by an Ariane vehicle from the French Guiana since 1981 for operating in geostationary orbit, and will be the third of the second generation of meteorological satellites. The two previous spacecraft of the second generation were orbited by Arianespace for Eumetsat in August 2002 and December 2005, and Arianespace has been also selected for the launch of the fourth and last satellite of this series, MSG-4, which is expected to launch early 2015. We are looking forward to continuing this fruitful cooperation with Eumetsat for the future Meteosat third generation.
Now, there are several key people in mission control as the mission director. There's also the range operations manager.
Yes,
he makes attention pour la séquence finale lanceur.
As you've just heard, he makes all the key announcements during the countdown and the flight.
That's right.
Top H0-7 minutes.
And this is him now announcing this key milestone in the launch. It's the last 7 minutes. It's the synchronized sequence or automated sequence. What's happening?
Well, the launch is fully automated in this 7-minute sequence. Right now, the onboard computers are running all the final checks before launch. They manage an impressive list of operations. Effectively, 2 computers are performing these checks. One is for the fluids and one is for the electrical systems. If there's any interrupt, for whatever reason, then the sequence will have to recommence at the 7-minute mark.
Teams have been working for weeks here at the Guiana Space Centre to prepare Ariane for today. This process is called the launch campaign. The campaign started as usual in the Launcher Integration Building, or BIL, where the various sections were assembled, both the main and upper cryogenic stages and the 2 solid propellant boosters. These highly skilled operations involve checking the electrical and fluid subsystems. Meanwhile, a few kilometres away, MSG-3 and EchoStar XVII underwent their own final preparations. All this in the extremely safe and secure environment of the dedicated building where cleanliness is paramount. These operations were performed in perfect cooperation between Arianespace and their customers' teams. The next step involved resting the spacecrafts on the top of the launch vehicle under the protective environment of the fairing. MSG-3 was placed first at the bottom and EchoStar XVII on the top. Exceptional skill was required when handling these 2 examples of expert engineering. At this point, the launcher and its 2 passengers were ready to start their final journey. The day before launch, the whole ensemble was rolled out to the pad, all fully integrated on the launch table with the umbilical tower and supply systems, ready to undergo the final preparations. Now, here at the spaceport, we're on the edge of the Amazon rainforest near the equator in South America. And we've had the last weather check 5 minutes ago. What's the weather like, Simon?
Well, it's supposed to be the beginning of a dry season, but recently it has been raining in the evenings. Tonight, we just have a scattering of clouds.
It's actually not bad, is it? It's quite a clear sky. Could rain stop a launch?
No, generally rain is not a problem, but we do need to monitor for other things. For example, the wind conditions on the ground, but also wind conditions at altitude between 10 and 20 kilometers. And we monitor for the storm clouds to avoid any risk from lightning. Today, the weather status panel is green, so we're good.
Now, the base is made up of a number of different facilities. There's the satellite preparation buildings, the integration buildings, and of course the launch zones. And the whole thing is known as the range. And of course that includes the ground stations, which are dotted along the flight path, which track the launcher as she flies over.
Yes, and all these facilities, these are dispersed across a very large area. In fact, the Guyana Space Center, it's equivalent to the size of Martinique almost. So you can imagine the logistics that we have involved in everybody communicating with each other, but not just here, but also across several countries.
And that's quite big, isn't it, Martinique? Mission Control is the nerve center of the range, 15 kilometers away from the pad, as we mentioned. But another key operations center is Launch Control, and that's only 3 kilometers from the pad. So whereas mission controllers deal with the whole mission, everything across the range, the launch controllers deal solely with the launcher itself. And you've sat in here a few times, haven't you?
Once or twice. There are 2 teams working here, one responsible for the ground operations and the other for the readiness of the vehicle itself. So the launch site operations manager, he heads up one group. He coordinates with mission control for the final authorization to launch. When all the conditions are right, he then okays this automated sequence that we're in right now. And the other team, he's headed up by the Ariane production manager. This team ensures the flight readiness of the actual vehicle, and it oversees all the operations from launch vehicle assembly to the moment of launch. There are over 100 people working in launch control right now.
All very cool, calm and collected. They've done this many times before. Now, this is launch zone number 3. It's just one of a whole set of systems across the range that we need to monitor. All those systems send their status to the boards in Jupiter Control Room, the status panels. You'll be seeing those in just a second.
Yes, that's right. There, as you mentioned before, it's a little bit like the dashboard in a car. They're all showing us the health status of all the main systems. The satellites, the launch system, that's the launch and the pad, the range, things like telemetry, the radars, the weather, the ground, and of course flight safety. They all must be green prior to launch.
And there they are on the left-hand side of the screen, and they are indeed all green right now. Now, the top of the launch vehicle, if you look three quarters of the way up, you can see what we call the cryogenic arms, those orange structures going from the umbilical tower to the vehicle. They're feeding cryogenic propellant to the upper stage. It's liquid hydrogen and liquid oxygen, and it's kept at extremely low temperatures.
Indeed, minus 250 degrees centigrade to be precise. You can't get much colder than that, and we need to fill these tanks right up until the very last moment, and that's because these fluids are so cold they're constantly evaporating.
There you can see them clamping onto the launch vehicle, and they will retract literally a couple of seconds before launch, so keep your eye open for that.
Yes, we start the Vulcan engine first, then we check its health before we ignite the boosters.
That's right, so we will have a 7-second delay between ignition and liftoff. Coming up to the 1-minute mark.
À tous de DDO, attention pour H0 moins 1 minute.
All electrical systems being switched to flight mode.
Top, H0 moins 1 minute.
We're live at the Guyana Space Center for the launch of an Ariane 5 ECA.
We're orbiting 2 passengers today, EchoStar XVII for Hughes and MSG-3 for Eumetsat. Welcome if you are just joining us.
Our very best wishes to our customers and to everybody who's worked so hard to bring us to today's launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage moteur Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Liftoff. Liftoff. Première manœuvre d'orientation du lanceur. Les paramètres à bord sont normaux, la trajectoire est nominale.
And there she goes, hauling herself against the gravity of the Earth. We've rotated to the east. We're heading out over the Atlantic. We're burning 3 engines, the Vulcan, which we did light on the ground, but actually it's those 2 boosters which are doing all the work here. In fact, their job's really to get us away from the gravity of the Earth, isn't it?
Yes, the boosters are providing 90% of the thrust right now, and each booster is burning 2 tons of propellant per second. To give you an idea, if you fill your car once a week, that's how much gas you'd use in a year.
And we're just hearing it. We're 15 kilometres from the pad, Simon. We're just getting the sound of the launcher as it flies over. In fact, we can even feel the vibrations, can't we? It does take a little while for the sound to get you, though, doesn't it?
Well, like you say, 15 kilometers from a pad, but we do feel it. And of course, those in launch control, VA2 will certainly be feeling this. It's quite sensational.
What's it like for the satellites in there?
VA2 will be feeling some dynamics right now. They get acoustic vibrations at launch. We flood the pad with water to dampen this effect, and then they get another round of acoustics as we pass through the sound barrier. Though the satellites are very well prepared for this, it's all part of a plan.
We're very lucky tonight. We are having beautiful clear skies. We could have had a few clouds, but we haven't. So we're getting these phenomenal images of Ariane as she flies through that what looks like a blue sky heading into space. And here on the left-hand side of the screen, you can see the trajectory. Just talk us through that briefly.
Yes, the curve, this is a computer simulation of the actual trajectory. The white dot on the curve, that's the actual position of the launch vehicle right now. The V means the velocity, and the A means the altitude.
Now we can see those boosters separating and heading back down to Earth. Basically, they've burnt all their fuel. We don't need them anymore, and there they are. We're losing weight.
Yes, we've lost about 3/4 of our weight, in fact, in just over the 2 minutes. The lighter we are, the more efficient we are, and the faster we can go.
Absolutely, and that's why we jettison parts throughout the flight once we no longer need them. So now the main stage is doing all the work. We can see it. That's the dot in the middle of the 2 boosters there.
That's right. It's a huge tank of cryogenic propellant, and it's going to burn for 9 minutes in total.
And the fairing is the structure that we saw earlier at the top of the vehicle, which is protecting the satellites from the rigours of the launch. One of those, of course, we haven't mentioned is friction.
Indeed, and yes, the launch is flying through our dense atmosphere at a very high speed.
And we're getting confirmation now that the fairing has separated. The fairing is, we're effectively technically in space, and you can see it, they're falling in 2 parts back down to Earth. We don't need it anymore because, of course, there's no friction in space.
Indeed, yes. The atmosphere is about 100 kilometers deep. Any remaining gas up there, it's so thin, the satellites are now safe from the effects of the atmosphere.
And there we go. We can see our 2 passengers for the first time. That's EchoStar XVII at the front and MSG-3 is behind, but we can't actually see it yet.
No, that's right. It's hidden underneath our black structure, what we call the cylinder, and it's designed especially to enable Ariane to launch 2 satellites at the same time.
And this year, the Arianespace family of launchers has grown to 3. It's been busy times at Arianespace. In May, it was mission accomplished once again for Ariane 5, when she successfully launched JCSat 13 for Japan and Venusat 2 for Vietnam. Arianespace has now launched over 300 satellites from the Guyana Space Center.
The next Soyuz launch vehicle from CSG is now taking shape, ready for an autumn launch. It'll carry 2 more Galileo satellites for Europe's navigation program. They'll join the first pair, which Arianespace launched during the maiden flight of Soyuz from CSG last October.
Arianespace has signed a contract to launch the DZZ-HR satellite for Kazakhstan. Built by Astrium, the high-resolution observation satellite will be delivered into a sun-synchronous orbit by Arianespace's light launcher, Vega.
The annual general meeting of shareholders of Starsem approved the company's financial statements for 2011. It also named a new board of directors, which renewed Jean-Yves Le Gall as chairman and CEO and Victor Nikolaev as chief operating officer.
During the SATCOM Africa conference in Johannesburg, Jean-Yves Le Gall and sales director Florent Deilly demonstrated how innovation can drive access to markets in South Africa.
Communications and IT professionals from over 100 countries attended this year's 22nd Communic Asia Trade Show in Singapore, where Arianespace reaffirmed its position as the benchmark launch service provider.
Jean-Yves Le Gall was one of 3 panellists during the plenary session at the G20 Investment Summit in Paris. The subject for debate was strategy and innovation.
Angelo Fontana has been appointed as special advisor to Jean-Yves Le Gall, consulting on decisions relating to the exploitation of Vega after its successful qualification flight.
Well, we're heading out across the Atlantic. What's our speed and altitude?
Just approaching 4 kilometers per second, and we have an altitude of almost 170 kilometers.
And we're burning the main stage. It's powered by the Vulcan engine, which we ignited on the ground, and it's extremely powerful, isn't it?
Indeed, and right now it's delivering more than 1,000 kilonewtons of thrust and in the vacuum of space. And if you think that 1 Newton is the force of 1 apple falling on Sir Isaac Newton's head, then that's over 1 million apples.
That's going to hurt. The Vulcan engine is actually built by Snecma, which is a company based in France.
It is, and this is the 1,200th engine in the Ariane family since the first launch more than 30 years ago. So congratulations to the Snecma team on this impressive milestone.
All the parameters are nominal. EchoStar XVII is our first satellite to be separated. Teams have been working for a couple of months here at the Guyana Space Centre to prepare it.
EchoStar XVII, with Jupiter high throughput technology, is the world's most advanced Ka-band satellite network. It will allow us to expand from our Hughes Net service from 640,000 subscribers today to an estimated 1.5 to 2 million subscribers in the future. HughesNet is a high-speed internet service to consumers in North America. It provides internet to the home, and Hughes has been selling this for many years, and EchoStar is just the next step in the HughesNet brand. EchoStar XVII builds on our award-winning Ka-band Spaceway 3 satellite, which Arianespace launched for us in 2007. It's currently carrying over 500,000 customers and is the world's largest Ka-band system. Once EchoStar is positioned in its orbital slot and testing is finished, we will launch our HughesNet Gen 4 service offering, providing a media-rich world like we've never seen before, of high speed, wherever people want to live and work. Hughes selected Arianespace for several reasons. First of all, you guys provided us a very successful launch for Spaceway 3. You have a proven track record with very good reliability and excellent availability. Plus, you have good customer service and you're very easy to get along with.
Now, we're tracking the launcher using ground stations as she flies over, and we've just received a signal from the second one. That's Natal in Brazil. For anyone who's not familiar with the flight, it's called telemetry.
Yes, and Ariane sends data to each of these ground stations. This tells us how the flight is progressing in real time. Later, we analyze this data to see how the vehicle has actually performed. That's what we call the Level 0 flight evaluation.
And there are 5 ground stations. There's Gaio in Kourou. There's Natal in Brazil. Ascension Island, which is in the middle of the Atlantic. Then there's Libreville, which is in Gabon, the west coast of Africa. And, of course, Malindi is in Kenya, which is, of course, on the east coast of Africa.
Extinction du premier étage sur commande de guidage.
Now, the main stage has cut off.
Séparation du premier étage.
The engine has switched off because it's burnt all its propellant, and it's now jettisoning the main stage. We're igniting the upper stage.
Certainly are. We started with 780 tons, and now we have approximately 28 tons left. So that's only 3% of our original mass.
Absolutely. We're certainly shedding weight. There's no question about that. So, Simon, we're now burning the upper stage, and its job is to deliver the satellites to their transfer orbits, which is the position in space where they can separate from the launcher.
Indeed. The upper stage It's a complex piece of engineering. Again, we're burning cryogenic propellants, for this time only 15 tons worth. And we'll burn the upper stage's single combustion chamber for approximately 16 minutes.
EchoStar XVII is an all-Ka-band broadband satellite, and it was designed and built by Space Systems Loral for Hughes. There's no question that EchoStar XVII is certainly a fantastic piece of technology.
Space Systems Loral is the leader in providing high-capacity satellites for broadband communications, with 4 decades of experience building communication systems using the Ka-band spectrum. EchoStar XVII, with Jupiter high-throughput technology, is an all-Ka-band broadband satellite designed to provide more than 100 gigabits per second capacity to Hughes' rapidly growing HughesNet subscriber base in North America. Based on the space-proven 1300 platform, the satellite was designed with a complex multi-spot beam architecture that focuses capacity on the areas in North America with the highest traffic demand, providing enhanced services for both consumers and businesses. It takes hundreds of people and more than 1 million man-hours to design, build, and test a satellite of the size and complexity of EchoStar XVII.
I'd like to take this opportunity to thank Pradman Kaul and his team for giving Space Systems Loral the opportunity to design and manufacture a very high-capacity satellite.
In alignment with its vision to create space-based solutions that improve the human experience, Space Systems Loral commends Hughes for its commitment to provide high-speed connectivity to the people of North America who might otherwise not have access to many of the important benefits of the Internet.
So we're coming up to 12 minutes into the flight, and the upper stage is powering us across the Atlantic. What sort of speeds are we doing at the moment?
Now we're at 7.3 kilometers per second, and we have an altitude of 170 kilometers.
I mean, these speeds are really quite something, aren't they? And really difficult to digest. It's so fast, and of course we're going to get faster.
Indeed, and if you think about this speed, currently the fastest man in the world, Usain Bolt, he would have to run more than 740 times faster to catch up right now.
That's quite an image. Don't blink at the London Olympics then. EchoStar XVII is the first satellite to be released.
5, 4, 3, 2, 1.
At Hughes, good is never quite good enough. That's why America's #1 choice for satellite internet is about to get even better. We're excited to roll out HughesNet Gen 4, the next generation of high-speed satellite internet service that will let people everywhere do more of what they want online. Making it all possible is the new EchoStar XVII satellite with Jupiter high-throughput technology. EchoStar XVII is the industry's most advanced, highest-capacity satellite. Adding EchoStar XVII to our network of advanced satellites, the best on-the-ground technology, and in-home devices, is big news for satellite internet users all across the country. It's the next step in our mission to help people live where they love where they live, and still stay connected. Of course, Hughes invented satellite internet, and for the past 15 years, we've been bringing all the benefits of broadband to people and places who could never get it before. Today, Hughes is America's leading provider of satellite internet. With the largest satellite network in North America, we continue to lead the way in innovation, constantly improving our network and our service, so we can offer internet that's faster, smarter, and better than ever. With the launch of EchoStar XVII, we look forward to introducing HughesNet Gen 4.
Today's launch is the culmination of over 3 years of dedication and hard work by many more people than I could possibly recognize at Hughes and our partners Arianespace and SS Loral. I would like to particularly thank John Celli and Jean-Yves Legal for being great partners. To the entire team, I say my heartiest thank you and congratulate you for this most significant accomplishment in our storied Hughes history. Designed with Jupiter high-throughput technology and well over 100 gigabits of Ka-band capacity, EchoStar XVII will expand our successful HughesNet high-speed internet service for consumers in North America from approximately 640,000 subscribers today to an estimated 1.5 to 2 million more. We'll then launch our new HughesNet Gen 4 offerings, delivering a media-rich world like never before. Thank you again to all who contributed to making this happen.
Internet service is all about what you can do. And with Gen 4, our customers will be able to do more. Connect with family and friends. Whether it's email or social media, it'll be faster than ever. Share photos, music, videos, and more. Uploading will be easier than ever. Shop, learn, chat, watch videos, download music. There will be more to enjoy than ever. It's a new day in high-speed satellite internet service. HughesNet Gen 4.
Now, we've had the signal at Ascension Island, so we're halfway across the Atlantic, and we call what we're looking at here the satellites and the upper stage. The upper composite, that's the upper stage, obviously, was the white cylinder we're seeing. You can see on the bottom left-hand side of the screen there. And then we have EchoStar XVII at the front. We've got a good glimpse of her there. And MSG-3 underneath the cylinder. That's the black structure there. It's a little bit like a small fairing, would you say?
Well, sort of. It provides the attachment support mechanisms for the EchoStar XVII. Though thanks to this cylinder concept and the impressive performance of Ariane, we can offer this dual launch capability.
And before we were using all our power to get away from the Earth, now we're using it to go faster and faster. MSG-3 is going to join an important series in space.
MSG-3 is the third satellite of a series of 4 satellites dedicated to meteorology from geostationary orbit. MSG-1 and MSG-2 were launched respectively in 2002 and 2005 and are fully operational. But MSG-3 is planned to replace MSG-1 that has by far exceeded its operational lifetime of 7 years. MSG-3 was built together with the other satellites and was put in storage for a period of 6 years. After storage, we had an intensive period of tests for a period of 1 year, and after that we had a very smooth launch campaign that led to the launch of tonight.
Images and data provided by the Meteosat second generation satellites are vital for the weather services, particularly in the area of nowcasting and short-term range forecasting, to develop applications associated with prediction of rapidly evolving phenomena which can be particularly dangerous. The importance of this mission is emphasized by the fact that today the imagery service for meteorological application over Europe and over Africa is solely provided by satellites of the Meteosat second generation. MSG-3 is particularly important in this respect because from one side ensures the continuity of a service, and this continuity in the field of full disk imagery mission, but also rapid scan service if necessary. It has both capabilities, obviously, as of satellites of this type, but also enabling the continuous improvement of the mission products which we have experienced and we will continue experiencing. Therefore, in this respect, preparing for the next generation, the Meteosat third generation, which will take over from the 2020 period onwards.
Well, we've now arrived at the west coast of Africa. We've had acquisition of the signal at the Libreville ground station. So we've crossed the Atlantic in just under 19 minutes. Incredible, really, when you think that it takes 6 to 7 hours in a jumbo.
And if you look at the curve, you'll see our white dot. It's right there on the line, and the flight is progressing exactly as we've planned it.
Arianespace is launching MSG-3 for Europe's intergovernmental meteorological organization, Eumetsat, and we are very proud to be part of this European story because the meteosats are so vital for predicting our planet's weather systems.
Eumetsat is an intergovernmental organization. We have 27 member states from EU and outside EU. And our mission is to deliver data, products, observations to the weather services of our member states, but also these products are used for climate monitoring. And in addition, we deliver all kind of support to our users to allow them to take the best advantage of these data and products. So to do that, we of course operate a number of spacecraft, ground segment, complex system to deliver information. Support to users is training first, because we are dealing with high technology, so we need to train our users to get them ready to use innovative data and products. Of course, we are also having a help desk, a user interface to help them understand what we deliver. We launched MSG-3 to make sure that we ensure continuity in a service which is critical to our users and to the Met services in particular. Why is it so important for our users? It's very simple to understand. Geostationary imagery is critical to see how fast severe weather is developing. And this is a sort of critical input to what I would call the last chance forecast. When it's real-time information, you get data every 15 minutes, and it's critical for the forecaster to appreciate how a critical situation may develop. Climate monitoring is absolutely required, because what is at stake is to construct long, consistent climate data series. And it's particularly important to have overlap between one satellite and the next in a series, to have cross-calibration, and to make sure that you can actually, through reprocessing, produce this long and consistent data series, what we call climate records.
We're heading out across Africa, and the flight path takes us virtually along the equator. In fact, French Guiana is the perfect position to launch from because it's on the equator, isn't it?
Yes, indeed. It's the fastest route to orbit, because even when the satellites are on the pad prior to launch, they already have almost a translational velocity of approximately 0.5 kilometer per second, and this is due to the natural rotation of the Earth. Basically, the closer you are to the equator, the more you benefit from this effect, and this is very beneficial for geostationary orbits.
That's one to ponder at home. MSG-3 was built by Thales Alenia Space, who are tremendously skilled and experienced in manufacturing meteorological satellites. In fact, they have a long and prestigious history in the field.
Meteosat is part of our lifeblood at Thales Alenia Space. We have been the trusted prime contractor for all the satellites since the 70s. Meteosat first and second generations, and the upcoming third generation. We have spent nearly 40 years perfecting our knowledge. And I can honestly say that when it comes to European meteorology, Thales Alenia Space is at the very forefront, both on the ground and in orbit. Through Meteosat, Europe supplies the best meteorological satellites in the world, thanks to ESA and Eumetsat, and plays a major role in the World Weather Watch. It is a great example of achievement between two European agencies acting on the world stage. At Thales Alenia Space, we are proud to be part of this success story. And we don't just build Meteosats, we also use our expertise to develop a wide range of other instruments and satellites, such as the Sentinels, JSON, and IASI. So today's launch of MSG-3 is close to our hearts. Our warmest congratulations to Eumetsat, the European Space Agency, and all our colleagues in industry. And our congratulations to the teams who have worked so hard on this mission. Good luck, everyone.
Absolutely. Now, we are 24 minutes and 15 seconds into the flight. Simon, speed and altitude.
We are now travelling at 9.2 kilometers per second at an altitude of 570 kilometers.
I'm just going to say that again. 9.5 kilometers per second. It's quite phenomenal, isn't it? We are climbing in altitude now, if you look at that curve on the left-hand side of the screen.
Yes, indeed. We are now traveling fast enough and high enough that we can efficiently change our direction and to best suit this mission. We have to get to 1,000 kilometers above Earth to eject EchoStar XVII first. Then we keep traveling to 2,400 kilometers where we'll eject MSG-3. But first, we have to put them in the right position, the right orientation.
There's the guests in Jupiter, in mission control, watching the screens.
Extinction de l'ESC, le second étage, sur commande de guidage.
So we have now upper stage engine cut off. The onboard computer has sent the command to switch off the engine. We are on the right path at the right speed to start releasing the satellites. The upper stage is now going through a very precise set of maneuvers. We're going to see it, there we are, it's twisting and turning. It's starting that process now. It's often called the space ballet. EchoStar XVII is the first one to be released.
After separation of the EchoStar satellite, we will plan to have initial acquisition within a few minutes. About 3 hours after separation, we'll deploy the first solar array, followed by the second solar array a few minutes later. Then we'll enter the orbit raising phase, where we'll have several apogee motor burns over the next 2 weeks to raise the orbit to its final position. During the end of that time, we will start our satellite bus testing. After that, and once it's in its final orbital position of 107.1 degrees west longitude, we'll deploy the antennas, we'll finish the bus testing, and then we'll do about 3 weeks of payload in orbit test. After that, we'll deploy the Jupiter high throughput technology. We'll do this by installing commissioning gateways around the country in several places, along with test terminals. And as we finish that up, we'll add some more alpha and beta test terminals to make sure that we're ready for commercial service. We expect to begin HughesNet Gen 4 service by the beginning of October. We at Hughes are excited to add a satellite as powerful as EchoStar XVII with over 100 gigabits of capacity to our HughesNet Gen 4 service offering.
So we're now in what we call the ballistic phase. That means without propulsion.
Yes, we are traveling high enough and fast enough, but we can cruise without these engines. You could say we're in celestial autopilot right now.
I like that, celestial autopilot. Every satellite needs to be positioned into a different orbit, and that's why the upper stage needs to move in any direction and twist and turn, as we said. That's how we orientate it. How does it actually work?
Well, there are a series of small thrusters on this upper stage. They give short bursts of cold gas, and this moves the upper stage. We don't need much power to do this.
And what we see when we're looking at these graphic images is actually what's happening in space, because the graphics are representing all those maneuvers
EchoStar XVII.
as they've been planned. And we now have separation of EchoStar XVII. A new baby is born. Congratulations to everybody at Hughes and at Space Systems Loral.
Fin de poursuite normale par la station de Libreville au Gabon.
Indeed, congratulations to everybody involved, and good luck to the satellite teams with the next phase of your operations.
Absolutely. Of course, EchoStar XVII is now heading out on its journey to its slot in geostationary orbit. During a campaign, there are about 1,200 people working here at the base. One of those is Martin Cordell.
Je m'appelle Martin Bourdel, j'ai 27
Hello, my name is Martin Bourdel. I am 27 and I am a specialist in guidance, navigation and control for Ariane 5. My responsibilities include guaranteeing the correct functioning of flight readiness of the electrical equipment related to guidance, navigation control of the vehicle.
Navigation, guidage et pilotage du lanceur. Sur le lanceur,
we can compare the launcher's electrical subsystems to the human body. The brain is the onboard computer. The sensors are like the balance sensors in our ears, which allow the launcher to orientate itself. And we have the nerves and muscles, which enable the launcher to pilot itself using what we call nozzle gimbaling. I am in the Launch Operations Manager team, and I report to the electrical assistant. Today we are in the final assembly building, integrating the batteries, and we are working with the industrial support team. We just connected the batteries on the upper stage in order to power the pressurization of the oil and thus ensure guidance of the upper stage motor.
Pressurisation de l'huile qui va nous permettre ensuite de piloter le moteur ESC. Nous pourrons ensuite venir les contrôler.
Then we check the upper stage motor from the desk in launch control. One of the operations involves checking the sensors on board to make sure everything is as we expected.
Relever sur le lanceur et les comparer à la configuration attendue. Le but est de garantir le bon fonctionnement de l'ordre.
The aim is to guarantee the correct functioning of the launcher sensor before and thus during the flight. At the beginning of the countdown, we switch on the different electrical systems and progressively configure them for the flight.
Nous allons les mettre dans la configuration qui est apte au vol. L'objectif
The goal is make sure the launcher is ready so the synchronized sequence can start. After training as an engineer specializing on onboard equipment, I joined the Arianespace team in 2010 and I started training in guidance, navigation and control on Ariane 5. With the arrival of Vega and the Arianespace launcher family, I was able to contribute my skill during Vega's maiden flight earlier this year. What I love about my job is that after weeks of working intensively on the preparation, we get to have the excitement of the successful launch and mission accomplished.
Avec un lancement réussi et une mission réussie.
Well, certainly a demanding job and very rewarding. I'm sure there are lots of young people who'd like to be in Martin's shoes. So there we have the upper stage with MSG attached. The black structure is the cylinder. There's everybody in mission control. What's our speed and altitude here?
We are currently doing 1,700 kilometers per hour.
Séparation de système de lancement double.
And we have separation of the cylinder. There it goes. It's that black structure. Simon, you work with the upper stages of the launcher. What's the mechanism for separation of the spacecraft?
Well, for this configuration, the spacecraft and the launch vehicle, they are connected at two circular interfaces. They are held together by what we call a clamp band. This is an extremely tight titanium belt. Pyrotechnic charges will then trigger this belt to open and release the spacecraft. Then a series of compressed springs, they will push the spacecraft on its journey.
So the satellites are effectively pinged into space, you could say.
Something like that, where the conditions have to be so precise.
Once MSG is separated, it too will undergo a series of operations.
Following separation from the launch vehicle, the LEOP phase will start. The LEOP is the launch and early orbit operations phase. It will be conducted by ESOC. It will be lasting about 10 days and bringing the satellite to the 3.4 west position on the geostationary ring where Eumetsat will take control of the satellite itself. The LEOP phase will be followed by the commissioning. The commissioning will be a phase lasting about 6 months, during which the in-orbit performance and the end-to-end performance of the overall system in space and on ground will be measured, and the meteorological products to the users will be validated before starting the routine operations of service. At the end of it, the system will be declared operational. MSG-3 will be renamed as Meteosat 10 and eventually moved to the 0-degree position where it will perform itself. I would like at this point in time to thank all the teams, in particular the industrial team for the satellite, ESA, the LEOP team at ESOC, Eumetsat, Arianespace and CSG for the support provided during the launch campaign.
I think, Simon, you had us travelling a little bit faster than we actually are earlier.
Well, I'd like to correct. We're at 8.4 kilometers per second.
We mentioned that every satellite's different, and now that it's separated, EchoStar XVII is stabilising itself on 3 axes. It's using its own thrusters on board to do this. What about MSG-3?
MSG, this is a spinner. That means it stabilizes itself simply by rotating about its longitudinal axis, just like a spinning top. Right now, we're actually spinning it up forward. The upper stage is rotating faster and faster, and we need a spin rate of approximately 30 degrees per second in order to separate correctly.
And that's why you can see it turning around and spinning. And what about EchoStar XVII? What degree was that?
Less than 1 degree per second.
Okay. It's interesting, really, because when we're watching these images in space, everything
MSG-3.
as if it's happening slow, but it's actually fast. And we have separation of MSG-3. Congratulations to everybody at Eumetsat and Thales Alenia Space. A job well done.
Yes, congratulations indeed. It's been a great campaign. Well done to all the teams involved.
And there we see Meteosat second generation 3 spinning off onto its orbit. It's a big day and the culmination of many, many months and for some years' work. Everybody's looking very happy there in Jupiter. It must be a great feeling. What's it like in launch control right now?
Oh, it's an intense feeling of a job very well done. They all know they played a key part. They all know they played a key part in this adventure. They will be delighted with today's success. They've all worked incredibly hard during this campaign. It is very intense. They'll also be wanting to relax a bit too.
I'm sure they will. And for some, of course, it's a bit of a quick turnaround for the next campaign.
Indeed.
I think they'll deserve a beer or two this evening, don't you?
One or two.
We're now going to be hearing from some of the key people involved in the launch. But you know, Ariane's job is not actually over because we do have some processes that we have to go through. We're going to have another look at that beautiful launch. Very lucky tonight, had some amazing images. Yeah, I was just saying that we do have a few processes because Ariane has to distance itself and we go through what we call passivation.
Yes, the last phase of operations. Yes, the last phase of the operations. We will orientate the upper stage, de-spin it, put it in a safe direction to the spacecraft orbits.
Good evening. As you've just seen, the 63rd Ariane 5 launch has just placed EchoStar XVII and MSG-3 in orbit. This is good news. First of all, this is the 49th success in a row for our launch vehicle, and that's a remarkable achievement. And second, because this evening's countdown has once again culminated in a launch on schedule, confirming the abilities of our operational team. Since the beginning of the year, and this is this year's third launch, we have been on schedule. So you didn't have to wait. And that is certainly a good thing. And finally, the two satellites that we have just orbited have once again demonstrated the flexibility of the Ariane 5 vehicle, which can simultaneously place in orbit one of the largest telecommunications satellites ever built for a private sector American operator, and one of the most powerful meteorological satellites ever developed for a European intergovernmental organization. So I want to warmly thank our customers, Hughes, EchoStar, Eumetsat, and ESA, as well as all of those who have come to attend the launch here in French Guiana. EchoStar XVII. I'm very pleased to turn this evening to our friends from Hughes. We launched the first satellite for Hughes on the 14th of August 2007. And I remember that launch because it was a milestone in the history of our company. When we signed the launch contract on February the 15th of that year, I made a commitment to launch the satellite within 6 months. And if you do the arithmetic from the 15th of February, you get the 15th of August. And we launched on the 14th of August. So we do what we say. We meet our commitments. And we were therefore on schedule, and I'm sure that's one reason why you entrusted the launch of your second satellite to us. The second satellite, the one we just launched, was built by Space Systems Loral. It's a very powerful satellite, and it will enable you to meet your customers' fast-growing demand for very high-speed internet services, not just in the US, but also in Canada. So I'd like to warmly welcome my friend Charlie Ergen, who has done us the honor of coming to be with us for this launch. And he, therefore, was at Toucan for the launch and saw the separation of the fairing. And I would like to congratulate you for this choice. Yesterday was Independence Day in the United States, and today Arianespace has enabled EchoStar XVII to become independent. At the time of separation, I saw someone saying Independence Day. That was not our idea. MSG-3, Eumetsat is one of Arianespace's most long-standing and most loyal customers. We've launched practically all of your satellites. And since Meteosat 2 was launched in 1981, you have entrusted all of your launches to us. I think we didn't do your first launch, but we didn't exist at the time. MSG-3 was built by Thales Arianespace, and it's the 9th satellite in the series. And I thank you very warmly for coming to us. I'd like to congratulate my friend Alain Ratier, who's been watching this launch from Darmstadt with representatives of the Eumetsat member states. And I also want to thank Ernst Kahnemann and Philippe Goudy for being with us here this evening. Now, beyond this evening's success, MSG-3 left a bit later than planned, and the next launch will be in Baikonur on September the 19th. That will be METOP B by a StarSam Soyuz launcher. So thank you to our customers, and I also want to say a word of heartfelt thanks to all of those who have been working hard in Europe and in French Guiana for years to prepare the launcher and its implementation facilities. And they have succeeded time and again in strengthening Europe's position in the international space sector. And I'm talking here to our friends in Vernon, who have told us that it is the 1,200th motor produced by SNECMA since the inception of Ariane, which is quite a lot, and I think they deserve it. I think our friends in Vernon will appreciate that. So self-evidently, with all of these successes, Ariane 5 works. It works well. Ariane 5 will be working for a long time to come. Following this launch, and thanks to all the contracts that we signed since the beginning of the year, 5 contracts for geostationary orbits, and we have a huge number of Ariane launches, and we've got 3.5 to sell to the end of the year. And thanks to all of these contracts, we have no fewer than 22 firm Ariane 5 launches in our order book. And if you calculate a rate of about 6 or 7 launches a year, that gives us more than 3 years of work. So thank you very much. Bravo to you all. And without further ado, I'd like to hand over to our customers, Adrian Mars for EchoStar XVII, Ernst Kahnemann and Philippe Goudy for MSG-3, and Joël Barre for Peace. Thank you.
Thank you, Jean-Yves. I'd just like to say to you and the Arianespace team and Wiener and Jacques and Clay, who I know is at Toucan, fantastic job. We're delighted we came back for the second time to you after the Spaceway 3, so a round of applause for your team. You know, as I said this morning, this satellite is one of the largest ever designed and built, and Space Systems Loral did the job, so congratulations to John Shelley and Andy Tillman, who's here from Loral, so fantastic job. Also, the satellite will have coverage over North America, including both the United States and Canada. And for our Canadian coverage, our partners ExploreNet and the CEO of ExploreNet, John Maduri, is here. So great job, John. So finally, just to the Hughes team and the EchoStar team, I think we started the paperwork on this in March of 2007 and went into the contract in the middle of 2009. So our CEO, Pradman Kaul, and our business leader, Paul Gasky, who's here from North America, were pioneers on this. Plus a lot of people, Bob Bushman, who's behind the glass right now and has been for, I don't know how long, but several days with Reza Razulian. They did a fantastic job. And also Dave Roos, who's somewhere here, and Stan Kay, who are our system engineering guys. So just to all the Hughes team and, you know, on behalf of Charlie Ergin and Mike Dugan, thanks to Arianespace, and thank you very much to everybody here in Kourou, and congratulations. And we're now going to put this into service as the most advanced broadband by satellite system in the world. So thank you.
Jean-Yves, as usual, I would like to take this opportunity to express my sincere thanks to Arianespace for the safe and very competent service they provided to us again for the launch of MSG-3, and you have counted the long history which we have with you with all the launches. My special appreciation also goes to our colleagues from ESA, Thales, and CNES, who operates the Kourou Centre Spatial Guyane. And last but not least, to our Eumetsat team here in Kourou, who all together worked so hard to make this successful launch possible. Now the work probably will transfer to the LEOP guys in ESOC and Eumetsat, and that starts now, and I'm confident that at the end of the commissioning phase, the continuation of our service from the geostationary orbit to our member states will be secured at least to 2020. And Jean-Yves, as you said, let me add a personal note. I take it for granted that you see us on the 19th of September, 11,000 kilometers east from here, for another successful Method B launch. Thanks a lot.
Okay, well, ladies and gentlemen, really, I want to say that this launch of MSG-3 is a great success for not only space in Europe, but also for all those people throughout the world who are using the data and the imagery from meteorological satellite. So really, all our congratulations to the launcher team, to the people here on the base from Arianespace, from ESA, from CNES, for extremely highly professional work really tonight. Also, of course, thank you very much for all the people who have prepared this spacecraft in Thales, in Eumetsat, in ESA, and our thoughts to the people that will be doing the commissioning and the early phases back in Darmstadt. We have a very efficient cooperation with Eumetsat. The story goes on. We are already working on the next generation of Meteosat series, Meteosat third generation. We are also preparing the METOP second generation series that will be tabled at the upcoming ministerial conference of ESA. So this is fruitful and long-lasting development that we have for, I would say, every one of us, for all of us using meteorology. But our next challenge, short term, is Baikonur, September 19. Thank you.
Bravo to all of you.
Merci. Donc,
thank you very much. So this was a success, and the next launch will be on the 2nd of August. Intelsat 20, which came here a couple of days ago, and HILAS 2, which will be arriving tomorrow. Once again, thank you so much. Bravo to all of you, and we'll see you in a bit less than a month for another launch. Thank you very much.
So it's mission accomplished once again for Arianespace. Congratulations to everybody who has worked so hard to bring us to today.
Yes, absolutely. Best wishes to our customers. It really was great working with you, and we look forward to doing so again soon.
So we have 2 spacecraft heading out on their journey to their final orbit. The best of luck to all the teams with the next phase of operations. Thanks for joining us here live at the Guyana Space Centre. From me, Katie Haswell.
And myself, Simon Thompson. Goodbye.